Okay, so operational amplifier is something which you might have already studied a bit, okay, a basic, but then we are just going to look into more details of this. If you just look into a simple design of an operational amplifier or the symbol of an operational amplifier, it is something like this, okay, if you remember. We basically have the output from this end, okay. We basically have the output here, and then we have got two inputs, okay. One is the inverting terminal and one is the non-inverting terminal. So if there is a minus sign, it's basically called as an inverting terminal, and if you are applying a positive potential at this end, this is basically a non-inverting terminal. Okay, so before I really give you all the points, I think this is important. On the other hand, sometimes it also happens that one of the terminal is grounded. Okay, so what is done is, this is actually nothing but we have got this as grounded here. Okay, and this is also how an operational amplifier works. Okay, so you know, in operational amplifier there is something which is called a differential amplifier, and it comes under operational amplifier. We have got the difference between these two, which will be the input potential. So before we begin, let me tell you this, that there are different ways of writing this down. Okay, maybe it will be just rubbed off and you will have this part. Okay, or maybe this part will be again rubbed off. Okay, and then you will just have a plus here and minus here. Okay, and at this particular point you are going to have got an output. Okay, so if you are taking on this part, you will basically going to get an output here. This is one part. Okay, so you basically might have a DC signal, okay, which can be amplified. Okay, on the other hand, if I just don't take a DC signal, I might have only an AC signal which needs to be amplified. So maybe I can just connect an AC signal here and get it amplified too. So you know, if you're considering an AC device or a DC device, both the places you can use an operation amplifier to actually amplify your signal. So the question is, why it is called operational, why it is an amplifier? Is it this simple block diagram that I've shown? The answer is no, of course. Okay, what happens usually is that in an operational amplifier, inside this particular part, the circuit is a bit more complicated than it looks. Okay, and this is something which we are going to handle in this particular unit. Okay, and this is what is operational amplifier is all about. Okay, so the thing is, what exactly happened with the operational amplifier, where did it originated and so on. So you know, when it was long back, when there were no such thing as digital computers, okay, and some operation needed to be made, it was actually done using operational amplifier. Okay, so you know, in mathematics, operation basically stands for addition, division, subtraction, or multiplication. Okay, so you know, if someone asks you a definition of op-amp, let's say, okay, if someone asks you a definition of usually it is op, okay, and then I think it's my mistake, I should write it this way. Okay, so I'll just take it in the right way of writing. It's op amp. Okay, so this is how we write it down. So we basically have the op amp. Okay, and the definition might be, is basically a circuit, okay, to perform, or that can perform, right, that can perform mathematical operations like addition, subtraction, multiplication, okay, division. So if I'm talking about amplification, probably I'm doing a multiplication or an addition, right? That is how the signals are usually getting amplified, but then it can also perform different other tasks. Okay, eventually we're going to look into this. Okay, so maybe we can just note down a few points here. Okay, you know, this is not a simple circuit. We actually have got a lot of component inside that triangle. Okay, so it's basically, it is a multi-stage amplifier. Okay, it is a multi-stage amplifier, and okay, consists of, and sorry, consists of differential amplifier stage, differential amplifier stage. Okay, and then we basically have got high gain CE amplifier, high gain CE amplifier. So common emitter amplifier. So if we are talking about transistors and we understood that part, here also we are going to use a similar technique, okay, to actually look into this. But then don't worry, we are going to explain these parts one by one. But right now we are just writing down the basic points here. And then there is a class B push-pull emitter follower, okay. So these push-pull amplifiers or push-pull emitter amplifiers is something which is actually taught in some universities at the undergraduate level. You might have studied it, but then anyway we are just going to study about this from the beginning, okay. Emitter follower, okay. This is there. So these are some important parts, okay. And then it is used in, okay, computers, okay. We can basically see any computer device basically having some op-amps there, okay. But nowadays everything has become so digitized that sometimes some of the operations which op-amp used to do previously, it is not done anymore, okay. But then it is still in use, okay. Video and audio amplifiers in communication devices. Okay, so this is how the operation in amplifier begins, okay. This is exactly what we should start. And I think I can just give you a basic block diagram here, okay. What happens here is this: we basically have got an input, okay, and if I don't go for this simple representation, that this is actually going to have three parts, okay, three main parts that we have. This is the first part, okay, and then we actually have got this. So let's take the second part here. So this is basically a block diagram of an operational amplifier. We're trying to understand this from the design point of view, okay, what are the different parts that we need and how these components are usually considered or usually designed will actually uh, have a role with the performance of the operational amplifier, okay. So what happens is this particular part, okay, is actually inside an enclosure, and this is how the operational amplifier. So this is basically something which you can consider as the symbol, okay. So this is the enclosure within which we have the operational amplifier, and then we basically have got the differential amplifier here, okay. On this part we actually have got the differential amplifier, okay. And the second stage we have got more stages of gain, okay. So we have got this, it depends on what kind of design it is using, but then if we are considering more and more stages of gain, we can actually have a different kind of design in the operational amplifier altogether, okay. So these are stages of gain, and in general it can be a high gain common emitter amplifier, okay. So this is just in general, we are writing it down as stages of gain because there are sometimes other more components which are also being used, okay. And at the end we have got the class B push pull emitter follower, okay. So at the end we have this. So at the end we are having this. So I'll just shorten, it's too small, okay, can't be observed, but anyway I think you understand this. Just write it as PP emitter follow, okay. So this is at the end. So this is basically the block diagram of uh, operational amplifier, okay. So this is the block diagram of an operational amplifier, and what we have here is we have got something at the input. So we are basically having this as input. It's basically a voltage signal that we are trying to amplify, and then we can actually get an output, okay. So there is something which is called the gain factor, okay. The operational amplifier's gain factor, basically it is denoted as A, and whatever may be the voltage. So let's say I have got a voltage, input voltage of 1 milliampere, okay. At the output I am going to get it as 1 milliampere into A. This gain factor is basically something which is doesn't have a unit, it's A, capital A, okay. And then maybe the value might be around, let's say 10 to the power 5, and then if that's the value we can just simply write it down as 1 into 10 to the power minus 3 into 10 to the power 5. So it's nothing but 100 amperes. So if we consider a practical operational amplifier, there are chances that you might be having an input of only 1 milliampere, but the output might be as high as 100 amperes. Okay, so this is what is important in this. And then this differential amplifier that we basically have is the key electronic component. Okay, so this particular part is very important. This has to be high end. Okay, key electronic component. So this is the main part of an operational amplifier, okay, the differential amplifier. Now that's where the input is basically getting to fed in, okay. So let me just write down few points here, okay. Okay. Points to note, okay, it's too small. Let me just, yeah. So the first point is the input stage of an op-amp is differential amplifier, okay. So input stage is a differential amplifier, okay. So probably I'll just use the notation DA again and again, okay. And the output stage is basically class B push pull emitter follower, okay. So if you just look into the output stage, we actually have a class B push pull amplifier. Oh, sorry, not amplifier, emitter follower, right? Emitter follow, okay. So that's there. And then might be one more point we can consider. You see, there is no such coupling as such. When we talked about transistors, or you might have studied it before, we can actually couple two transistors and make multi-stage transistors by, let's say, RC coupling and so on. There is no concept of coupling here, okay. So that is the reason that actually it's different, okay. So internal stages are directly coupled. They are directly coupled, okay. So what we can say, maybe we can include that no coupling capacitors are used. Coupling are used, okay. So we have that's direct coupling, okay. So that actually is good because we have got less electronic component there, and it because of this it can amplify both AC and DC signal. Eventually we are also going to talk about AC to DC and DC to AC converter, okay, and that is also something which can be done by an operational amplifier, okay. We actually use that, okay, and it has got very high input impedance. Input impedance being high is very important, okay. If you're considering an ideal op-amp, it is basically infinite. In an ideal op-amp, the input impedance is infinite, okay, and very low output impedance and very low output impedance, ideally zero. So we want to have the maximum input, okay, but then we have got this, okay. So that amplifier will actually draw a very small current if we actually have got a very high input impedance, okay, from the signal source. So basically what happens is, if I'm going to amplify the voltage, okay, the current, if it is drawn minimum, okay, that is something which is more ideal in nature. So this effect of very low output impedance is that the amplifier will usually provide a constant output voltage, okay. So if there is any current which is drawn and we have got an output voltage which we want to amplify, and if there is any kind of current drawn, then that will actually have an effect on this output. But then if the current drawn is not there, if the current ideally is zero from the input, we basically have an amplification only of the voltage, okay. So this helps to have a constant output voltage without any input current signal. Okay, so this is why it is basically important to have a very high input impedance. Okay, and the gain factor that I was talking about, okay, is there. Okay, maybe I can just take one more slide. Number 4, op amp has a high gain. Okay, so basically a high voltage gain. So ideally it should be infinite. Okay, it should have an infinite voltage gain, but there is always restriction. But then it is typically more than 20,000. Okay, it's not 20,000, sorry, 2 lakh. So it's there. Okay, it's basically have that way. Okay, so mostly operated with negative feedback. Mostly operated with negative feedback. This was the basics of op-amp, so that's why like we are just going to take all these points one by one and going to understand this. Okay, so when we look into an op-amp, we're basically going to look into something which we call as the first point is differential amplifier. So we basically have got a differential amplifier. So what happens usually is that if you're actually having a differential amplifier, what we do is we are actually going to amplify the difference between the signal. Okay, is basically a circuit, you can just write down the complete sentence. Okay, that can accept input signals. Okay, it can actually accept 2 input signals and amplify the difference between them, and amplify the difference between them. Sometimes if you are actually having 2 different signals, you can always amplify it. If you can just look into this previous diagram here, I'm talking about a 1 milli amp signal. Okay, oh sorry, I'm talking about voltage here, so let me just write it down as millivolt. Sorry, someone should have corrected me here. Okay, so we're talking about voltage here. So if you basically have got a 1 millivolt signal at the input, we are basically going to have a high output. But then if 1 millivolt, I'm saying that means at this point it is 1 millivolt, at this point it is 0, because this is grounded, and that is why this is basically having a single input. Okay, but on the other hand, if you just want to have a double out input, you can always do it. Okay, maybe you can actually have a signal of 10 millivolt at this particular point. Okay, and at this negative for the inverting terminal we can have a signal of 2 millivolt. So basically it's going to be 8 millivolts, so that is going to be 8 here. Okay, so this kind of operation where we are actually going to amplify a signal which is actually the difference between the 2 terminals at the input, is something which we use as a principle of a differential amplifier. Okay, so this is again important, and we also need to understand that we are actually amplifying a signal which is um, low to a high value. Okay, using the voltage gain factor of the operational amplifier. So all these actually has got some kind of application. Okay, so if or you can always get these kind of questions. Okay, it is very simple, and I think it's not there complicated. What happens usually is sometimes I've seen, if you're lucky, you might get this simple question even in your exams. Okay, even in entrance exam also, the only thing they want to know is whether you know the concept or not. Okay, so a differential amplifier, let's say, has an open circuit voltage. Okay, has voltage gain, sorry, let's say 100. The input signals are 3.25 volt and 3.15 volt. You have to determine the output voltage. So you know, if you can just find out the output voltage, is very simple in fact. Okay, it's not at all difficult. So these kind of questions will always be there. Okay, it might be there. If you're lucky, you'll get these questions. Okay, so if you want to just find out the output voltage, V out, the simple formula is you have to know what is the gain. So you know, this is the voltage gain that we have. Okay, so this is the operational amplifier's voltage gain, that is clear. And then you can take V1 minus V2. Okay, so input signals are this and this, so you can just take the difference. So it is nothing but 100 into 0.1, right? So if you just take it, to get the answer is 10 volt. So this is the basic use of an operational amplifier. Okay, so this is there. Now you see, if I actually applying two different signals, I take the difference between them, multiply it with the gain, I get a value. But you know, many operational or amplifiers are there which are actually having much greater gain than this. Okay, so it depends on what kind of instrument you are using. So this is a very straightforward question, and this straight away tells you what is the usual application of an operational amplifier. Okay.